All right, so this is lesson 10 on scatter plots and lines of best fit. So this table shows the average statewide temperatures from 1999 to 2013 for Mississippi, and then this same data is graphed in this scatter plot. Notice that the x-axis is years since 1999, so 1999 is year 0, and then all of these are like 1, 2, 3, and so on. So when you look, you're not graphing 1999, you're graphing the year since. So, when data is displayed in a scatter plot, then it's often helpful to represent the data with a linear function. In order to predict unknown values that are not on the data set. A trend line, or line of best fit, is a straight line that best represents the data, hence line of best fit, on a scatter plot. The line may pass through all, some, or none of the points in the data set. So if we're approximating it by hand, we're going to create a scatter plot of the data, try to choose a line where the plotted points are as close as possible, find 2 points that fall close to the line, calculate the slope of the line through the 2 points. Remember, that's the formula y2 minus y1 over x2 minus x1. That's the formula we're going to use right there. Estimate the y-intercept, which you could use either point slope form or y equals mx plus b, and then write the equation of the line. The equation can be used to predict information that is not plotted on the scatter plot. Consider the data from the average Mississippi temperature since 1999, so the thing we were just looking at. Formulate a line of best fit for the average temperatures since 1999. So if I had to guess, my line of best fit would be something like this. And we're going to choose 2 points that are very close to being on that line. I think I actually drew it a little lower, maybe not quite as slanted as it should have been, but I'm going to pick this point and this point. If we go back to our table, we can tell that these are the points 1, so that's 1999, here's your table, 1, 70.6, and I'm going to pick the point 14, 71.6. So that's 2007 would be 14, 71.6. I'm going to use those two to find the slope. So I have 71.6 minus 70.6, y2 minus y1, over 14 minus 1, which gives me 1 over 13. So my slope is 1/13. Then I go back into my y equals mx plus b. So y equals 1/13, that's my m, x plus b. And I'm going to sub in an x and a y from one of these points. The easiest point to use would be 1, 70.6, so that you don't have to multiply by anything besides 1. So I have 70.6 equals 1/13 times 1 is just 1/13 plus b. So when we subtract 1/13 from both sides, I get 70.6 minus, I would put the 1/13 in parentheses so it keeps it all together, 70.52, which means my equation, putting it all together, is 1/13 x plus 70.52. Then I need to use that equation to predict the average temperature in the year 2020. So remember, my x represents the years since 1999. So if that's the years since 1999, then 2020 minus 1999 is 21. So my x is going to be equal to 21. So I'm finding f of 21, or when x is 21. So y equals 1/13 times 21 plus 70.52. So that gives you 72.1, since we're talking about temperature, 72.1 degrees. Predicting values that fall outside the given data or values that are in the future is known as extrapolation. So doing it by hand is definitely one way that you can find the line of best fit, but the most common way of finding the line of best fit, and probably the most accurate way, is using linear regression. The good news is your calculator will do that for you. So I'm going to walk you through how you would do it with a calculator, but be sure to practice this on your own at school when you have a calculator at some point. So the first thing you're going to do is you're going to go to Stat, the same places we went to for our one variable, mean, median, mode, all that. So you're going to go to Stat, enter on Edit, or hit the number 1. You should see L1, L2, L3 up here. If one of those L's is missing, then either notice which L's you're putting it in. So if you're putting it in L2, L3, just note that, or you can reset your calculator. To reset your calculator, you're going to go to second, and then the plus sign, and then follow the directions from there. So let's put this data in L1 and L2. So L1 is going to be my total fat. And then L2 is going to be my total calories. All right, let's make sure I typed it in right. Okay, cool. So you have all of your data in here. Now we're going to actually graph the scatter plot. So to graph a scatter plot, you're going to go to second, y equals. So second stat plot, which is at y equals. Hit enter on number 1. You're going to have to turn the plot on, so hit enter. It looks like nothing happens, but it actually highlights the on. Make sure it's set to this, which is a scatter plot. Your X list should be L1 or wherever you typed this X data. Your Y list should be L2 or wherever you typed the Y data. If you need to change this, then you're going to hit second and then either 1, 2, 3, 4, 5, whatever. So all that's set right. I can enter through all that. And then I can go to graph. If your scatter plot isn't showing up when you hit graph, then hit zoom and go down your list until you see zoom stat. So zoom 9, there's your scatter plot. So you can see that it has a positive correlation. It's going up from left to right. Then we can have our calculator determine the line of best fit, the line that would best fit through the center of this data. So to do that, you're going to calculate something. So we're still going to go to stat, but since we're calculating something, we're going to calc. And we're going down to number 4, which is linear regression. Okay, so then we're going to hit enter on linreg. We're going to make sure our lists are right. Again, if you happen to put it in L2, L3, or different L's besides L1 or L2, then change those to match. You do that again by second and then whatever number. So L1 is above 1, L2 above 2, you know, you get it. So then go to calculate, hit enter, and this should pop up. If for some reason at this point it says invalid dim or anything super weird, then reset your calculator and then try it again. So it gives us an A value and a B value. So my A value is my slope and my B value is my y-intercept. So I can write that down in my workbook. So that gives me y equals 12.79x plus 63.61. That's what they got in this picture right here. Then we've already graphed our scatter plot. We can now take this and graph this equation as well. So I'm going to go to y equals, type in 12.79x plus 63.61. And you can see that that line goes straight through the center of that data. It's much more accurate than if we had tried to make our own. So we're going to use the formula to predict the total calories of a panini sandwich with 12 grams of fat. So 12 grams of fat is going to be my x. So I have y equals 12.79 times 12 plus 63.61. which gives you 217.09. So there are about 217 calories in the panini. Predicting values that are inside a given data set is known as interpolation, or intrapolation, I guess. Okay. Moving along. Consider the scatter plot of sandwiches. Formulate a line of best fit for sandwiches without the use of technology. So if I'm trying to do this without technology, same line, I'm going to put the line about through here. Now, without technology, I'm going to have to use points that are just close to the line, or if when you draw your line, you can see 2 points, use those. Okay, so if I'm going to formulate a line of best fit for this one, I would use 2 points that you can determine about the coordinates for. So we could guesstimate that this one is at 6, halfway between 120 and 160 is 140. And then that this one is at about 12, halfway between 200 and 240 is 220. So 12, 220. Then I have the slope is going to be 220 minus 140, which is 80. And then 12 minus 6, which is 6. So 80 divided by 6, which is 13.3, repeating. So your slope for that is about 13.3. So then if I fill that into slope-intercept form, I'm going to use the 140 point. So 140 equals 13.3 times 6 plus b. So I still have my 13.3 times 6 plus, well, okay, so that's 79.8 plus b. I'm going to subtract that from both sides. So I have 140 minus 79.8. And that gives me 60.2 as my y-intercept. So then my equation is 13.3 x plus 60.2. I can use that just like I did the other one to estimate the calories from a 12-gram panini. So that's 13.3 times 12 plus 60.2. Which gives me 219.8. Then your last question before we beat the test says compare the graphing calculator line of best fit to the line of best fit that was formulated without the technology. Which method do you think is more accurate? So before we got 217.09, now we got 219.8. So we're in the same ballpark, we're close. But the more accurate one would be the calculator, not just because it's a calculator, but because it does perform linear regression, which actually finds the middle of the points instead of just estimating. I could have picked any points on here. I could have drawn this line a little differently, and it would have been off by a little bit. So last be the test. I'm deciding which 2 data points would be used to determine the line of best fit. So we could look at each one of these. So 31.5 would be this point. 38.3 would be this point. So that line would be really far off from the center of the data. 38.3 would be this point, and 53.6 is out here, so that's really far from the data. 20.15 would be this one. 31.5 would be this one, so that's a little below the data. And then 20.15 and 53.4, that would be this one right here and this one right here. Do make a line that goes straight through the center of the data. So D would be the correct answer for that. As always, let us know if you have questions.